Hi guys, so today we are on a road trip. Cyprus Amateur Radio Society has come to the British radio station in Cape Greco, and we're gonna go inside in a bit, and the guys will give us a tour, so stay tuned and see on the next couple of minutes what will happen. Έχω βίντεο ρε.
Έχεις βίντεο.
Μιχαλή ήδη.
Έτσι.
It is documented anyway.
Basically here in Cape Greco, we had two main systems. We had one system made up of 2 blocks, which gives a combined power of 800 kilowatts. And then we have on the other side a system of 3 blocks, each block being 500 kilowatts. So we had a combined power of 1.5 megawatts. So we have 2 antenna systems. We have the antenna system on this side of the site, which is made up of 3 towers, 3 active towers, which these are connected to. So that system there has a maximum power handling of 1 megawatt with the 3 towers. The system we have on the other side here, which is made up of 4-phased antennas, this one has a maximum handling power of 2 megawatts. 2 megawatts, but the maximum power that we have put on that unit was 1.5 in the beginning, but we had a problem. We couldn't run the system at 1.5 megawatts because on the rejection filters we have, each system has rejection filters to take out the other frequency. So this system has a rejection filters for 1033, and this system over there has rejection filters for 990. The problem that we had on this system was that because we were pumping so much power into it, where we have the rejection filters, I don't know, some of you will know, some of you might not know, above the rejection filters, we had a corona effect. A corona effect, what is a corona effect? A corona effect is because you have such a huge magnetic field, because we're now talking about megawatts and not watts, basically you have the rejection filter. You have a huge magnetic field around the coil. There where the magnetic field reaches its equilibrium and you have the air molecules sitting, because the magnetic field there is so high, it actually energizes the electrons and it starts making the electrons oscillate on the surface of the magnetic field, which you get the effect of, it actually turns the air into argon. So you get this blue haze. This blue haze even makes aluminium burn. We're talking about temperatures over 2 million degrees at this exact point. So that was the first problem we had. And the second problem we had, which was, I've never experienced it before, the rebar within the building, even though all the rebar are welded together, we were having arcings from one side of the room jumping to the other side of the room due to the power. Again, we're talking about huge powers. This station was until the 31st of December, the second biggest medium wave station in Europe. We were the biggest up until last year when they opened a new station in Hungary, 4.5 megawatts.
One year, such an amount.
Huge amount. Huge amount.
Belong to whom?
To the government.
Of
Medium wave?
Hungary?
Yes.
Medium wave.
Medium wave. Yeah.
But Hungary needs such a power of...
Their philosophy is that the Hungarian government say, anywhere in the world where I have a Hungarian, I want to be able for him to hear the news. It's political.
It's such an economy.
Okay. Us here, we were the second biggest client of the Electricity Authority of Cyprus. On 1 meter, not to misunderstand. We're talking now about 1 meter. The biggest client of the Electricity Authority in Cyprus at the moment is the government. But that's because it has the army camps, the hospitals, so it's not on 1 meter.
Subdivided, yeah.
Our electricity here, average now over the last year where the electricity has not been too expensive, we were averaging the month 150, 290,000 a month. When the electricity was expensive, 2014, 2015, we were pushing 300,000 a month. Our load here was 2 to 2.5 megawatts. So it's a huge load. Now someone can say to me, but these units are inefficient. These units are the most efficient you can find today with 97% efficiency.
As much.
Yeah. The FM, I think the best is 70, 72, 80 now. So you can see it's quite a difference. Let me show you, I've opened one block so you guys can see. So come all around as much as you can. Each unit on these, each unit is made up of 512 amplifier modules. These are the modules here. Each module has an output power of 4 kilowatts.
4 kilo each.
4 kilowatts each, okay? So they're all combined and they're all phased together to be able to give you on these units an output of 400 kilowatts. So the two outputs of these units are combined in here, which is the combiner, okay? And from here, it goes out. It goes out. This system here had the ability to have one on air and one in maintenance mode, or both together for reliability. The system on the other side had the ability of either having the 3 blocks on air on a reduced power, so we wouldn't go above 1.2 megawatts, okay? Or a combination of 2 on air and 1 in maintenance mode, which was normally how we ran the systems. This one was hot, both units. On the other system, we normally, unless we had requests to increase the power, because you know, going from 1 megawatt to 1.2, you're talking about 0.8, 0.9 of a dB.
Oh yeah.
For the power that you consume,
for
the end user, it's not so much. So unless we had a specific request, either from Washington or from Paris, to increase the power during the day, we had them running, these were running at full power. Over there we were running at about 90%. And normally we would only go full power if it was something during the day where the propagation isn't as good as it is at night, we would pump up the power. But normally at night, with the 800 to 900 kilowatts, we had a coverage. We could go with the one system, which is the P3, which is made up of the 3 towers. It was designed from here. We had a coverage up to Johannesburg from Cyprus. On the P4 system, which is designed to go from Cyprus, Syria, going to the Far East, we had a coverage up to Hong Kong. We could cover up to Hong Kong, running on a full power, and if the propagation was good, and we could phase. We had the ability with these systems to phase the antennas to change the tilt. So because these antennas are what you call a skip antenna. So basically what we do is we go up to the ionosphere and we come down.
Oh yeah.
In that way you have these huge hops. So you have a first lobe at 5,000 kilometers, then you have a second lobe which is down 3 dBs at 10,000, and then you have a third lobe at 15. But the 15,000 kilometer is not classed as your target. Your target is maximum up to the second lobe. The person getting the third lobe, he will hear it, but he will be 15 dBs down. So if he's not having a very, very good coverage, you're going to drop out. So your goal was the first and the second. And depending on how you phase the antennas, you could move the lobes back and forth. To change the frequencies on these, on the units themselves, it's a very simple procedure. But on the antennas, it's a very complicated procedure. Because you'd have to, I'll take you down and you can see, you'd have to rephase and retune basically the capacitors. Not so much the coils, because you stay within the band.
Is there any reason to change the frequency? Was it something that you did often?
No, very rarely. We did on this one, 990, because when this frequency was issued to us from the Cyprus government, because medium wave frequencies belong to the state, are state assets.
Okay.
The problem being that because, as you know, when this system went online on 2000, okay? 990, based on the ITU who are the ones who will give you the final okay, Iran had 2 transmitters running on 990 local, medium wave, 10 kilowatts each. And we did have a clause in the license that stipulated that if we interfere with them, we're obliged to drop power, because 990 had been issued by the ITU to Iran back in 1968.
Yeah.
But because it was, US government, Iran, ITU, the Cyprus government didn't want to get into that grief. So we ourselves tried to keep the power down as much as you can. But again, as you all know, medium wave, you don't have so much control on where you're going to hit, because as you know, the ionosphere, it's not a flat surface. The ionosphere changes in density, and as it changes in density, you may get a lobe do this, and then afterwards you may get a lobe do that.
Yeah.
So it wasn't the easiest thing. Up until 2010, the Iranians didn't complain so much. After 2010, when they started to complain, but okay. On the frequency we had for the French, it was unique, this particular frequency, to the Middle East, so we didn't have issues on interference. The biggest issue was interfering with another country. Okay, as the spectrum now becomes cleaner, it's easier to get frequencies, but the problem is that, unfortunately, you have now this argument between, how to put it without sounding, the newer generation, who the only thing that they think of is internet. Yes. The internet is a great thing. If I'm sitting in my house in Nicosia, or in New York, or in Paris, and I have a 50 megabit connection to my house, yeah, sure, I can listen to the internet. But I guarantee you that 99% of people sitting in their house are not going to stream and listen.
Of course.
The other thing to always keep in mind is that you have war, you have civil uprise, or you have environmental catastrophes. The first thing that goes is the GSM network. The second thing that goes is the internet.
Maybe the other way around, but
They're both.
yeah.
Normally, if it's a war zone, the first thing that the government shut down is the GSM
Yeah.
for security purposes.
Of course, yeah.
And then you also have the third factor, which the 2 factors, we can all suffer from it. The third factor is quite unique to the Middle East, Africa, and Asia, where you have the government factor. Where the government factor, at any moment, come in, turn off the internet, and nobody hears nothing. And this has always been my argument to my people above me, who have a tendency to listen to the IT people, and I always start the conversation and I say to them, have you ever been in a war situation? Or have you ever been in an earthquake or a tornado? In those cases, the only thing that you know is going to work is your $10 transistor radio.
Yeah.
Now, the biggest issue or the biggest argument that people have had with medium wave is that, yes, we do have the coverage, but the audio quality is not the best.
Quality, yeah.
It's not the best, simply because you pick up a lot of ground noise.
Yeah.
With the new DRM system, which these are all modified and ready to go, you go to digital medium wave. Digital medium wave has multiple advantages. The first advantage is, for every 1 unit now, you can have 3 carriers, 3 audio carriers.
Yeah.
So for the price of 1, you now have 3 programs. You have the ability to run in a simulcast, where you can have 1 digital carrier and 1 analog carrier. Of course, your analog carrier is 3 dBs down from if it was only in an analog mode.
Okay.
Okay, so you sacrifice a little bit on the analog coverage, but you now have the digital coverage. Normally people do a simulcast of the same program to make people start to switch, and then they switch off.
Okay.
I haven't seen radios.
There are. Unfortunately, we come back to another interesting dilemma. And the dilemma is this. What came first? The chicken or the egg? And why do I say that? Because the broadcasters say, okay, I'll buy the transmitter. I'll install it. Who's going to listen to it? The end user says, okay, I want to listen to a digital program. I'll buy a radio when there's a digital program on air. So you understand? It's what came first. Now what has to happen is this, because this argument, it's not unique to this. This argument started when we started having the conversation between analog FM and DAB. The advantages to DAB are huge. But again, it was the same thing. The person sitting in his car was saying, yeah, I would like to listen to DAB, but why should I go and buy a receiver that's useless?
Is there something like a converter where you can plug in it to an analog receiver?
Yes, there are lots, because what has happened is now the first country in the world that has gone full DRM, and sometimes people say the Western countries are in front and the rest of the world is behind. Well, in this case, the first country that has installed 22 100 kilowatt DRM units is India. India has a full DRM network. The other huge advantage of the DRM is that you can now send data. So the new receivers, you can send pictures, you can send audio files, but the most important thing, you can warn people.
Yes.
So it's a very powerful product. We have tested in cooperation with the French military. What have we done? We've taken 2 ships and 1 land base. We've installed 3 DRM transmitters, 2 on the ship out at sea, 1 on land, and we've been able to make our own hotspot using the DRM transmission to transmit data. So you use the medium wave, not for audio purposes, but actually for instant Wi-Fi networks.
How about the bandwidth though on the transmission?
You heavily compress. You heavily compress, but because the algorithm is specifically designed for the existing bandwidth, you can actually put a lot of bandwidth through it.
Okay.
If you don't have an audio program, I've actually seen running video from these. Okay?
Okay.
It wasn't the best, but if we go back 10 years to how it used to be using YouTube, 10 years ago with today, there's no comparison. Today you can have a 4K streamed, where 10 years ago you couldn't even get a PAL quality stream. So as the algorithms improve and as the spectrum empties out, because the biggest issue you have on these with the bandwidth is the spectrum. I mean, under normal circumstances, you should be 10 megahertz. We here always had the span open simply because, 1, we had no one beside us, and 2, if your span is a little bit expanded, it sounds better, and you also stop people popping up beside you because they know they're going to have an issue. Okay? You can do that when you've got no one beside you. When you have somebody above you and below you, then it's critical that everybody has a very tight bandwidth. Otherwise, you make issues to them, they make issues to you, and in the end you all lose. You know, it's the same discussion that Mike can probably tell you that most of the radio stations in Cyprus have had with the Turks on the FM band. You know, and for someone who owns a radio station but doesn't understand, they think, oh, let's put power. Doesn't work like that. You'd need to be 5 times higher power than the one that's interfering with you to be able to stop. And then all it takes is him to go up by 1 dB, and excuse my French, you're screwed. So it's a non-winnable. You either do it civilized and speak to the other guy and say, okay, at least leave, like on the FM spectrum, 200 between each to be clean. The best is 300, but unfortunately can't do that anymore because there's a huge demand and it's finite. This problem will be solved. Cyprus will solve this problem that they have with the Turks and with the Arabs when they go to DAB, because you now leave the FM band completely and you go to VHF.
Yeah, last year I think the Turks brought a radio station from Turkey to the occupied site, and they were streaming on the same frequency as Cypriot channels, and we couldn't.
That happens all the time.
And we couldn't listen to the radios.
Yeah, that happens all the time. I mean, I know from experience, Radio, Brodo and Super, they have this issue on quite a few stations. Because you have the Turk who does it on purpose. There's no other explanation. I mean, from an engineering standpoint, it is illogical to try and be 150 above or below someone. So what they do is they make local transmission points on the north, covering a small area, but pumping power. So I can't affect him because it's a very small area he wants to cover, but he affects me because I'm trying to cover a very large area. So the further the area, the more lobes you're starting to get. So that's a little bit on this side. On here, these are the control units. I mean, okay, it's closed, but you walk into these units. This is the corridor where you walk in to see up the pickups. So you have the control units there, and the supply units here, and then the interconnection units there.
What is the running voltage of those things?
11 kilovolts. We put 11 kilovolts, you can see from here. It's direct. Yeah. The transformers on these are 4.5. The transformer here has a weight of 4.5 to 4,500 kilos each. For the unit or the output of the transformer, but it's 11 kilovolts. This is a dummy load. This is an 800 kilowatt dummy load, and in there it's a 1.5 megawatt dummy load. Everything is water cooled. These are both liquid cooled and air cooled.
With such an amount
It's
of
combined.
with
Yeah.
such an amount of heat.
The easiest thing to change frequency, because you may need to actually change coils. And when we go down, and I'll show you downstairs, coils are expensive because today there are only 3 companies in the world that do the antenna side of things, that do the multiplexing. It's a very specific science, and it's a science that requires a lot of experience. Again, Mike will tell you, on paper it's all easy. On paper I can send you to the moon and bring you back, but in practice it's a completely different story. So this is one of the main factors why these systems, you don't see many of them anymore because they're expensive. I mean, the antenna system for the P4, just the antenna system without all the matching, it's 4 million. Because the antennas are quarter sine wave. So that's why these are 133 meters. 133 meters because it's quarter sine wave. You couldn't have a full sine wave because you'd be talking of something over 1,000 meters.
We were wondering about that. See, you were thinking that around 40 meters. I had no way for
there's only one other tower in Cyprus that is higher than our towers, and that's belonged to CYBC, and that's their medium wave just outside Nicosia, which is Simulov, which is 200 meters. That's the highest on the island. But on the medium wave, we've the highest, and then after us are
quarter.
Ours are quarter. No, it's not. It's not, because you see the difference is
Maybe it's 5/8.
yeah. Theirs is also 360 transmission. Ours is directionalized. We have a very, very high back to front ratio, simply because, you know, Cape Greco has had military installations since 1947. the first people to come here were the Brits.
Yes.
The Brits were here until the end of the Suez Canal War. All of the British military radar was here. That's why outside, if you see on the side, we have lots of concrete square blocks. These will actually set up the antennas. Because exactly, originally they were mobile. Then they moved to the mountain behind us and they had the fixed system there. So we had the links coming here, and then from Cyprus we had a direct link from here. The power there was 100 kilowatts at 3 gigahertz, so you can imagine. And we were going directly to Tehran. And from Tehran, we were bringing it down, bringing it back up, and we were going straight to Singapore. So this is how they had a link from London to Singapore direct.
Why is that?
Via Cyprus. Once that system came down, then the French came in 1970 and started the procedure here. And from 1971 onwards, they've been transmitting from here. In 2000, we started as an uplink, a downlink and an uplink station, because Cyprus is unique. Cyprus is unique in many reasons, but we're also unique in that the location of Cyprus, we have the ability from Cyprus, our horizon for satellite transmission and reception goes 110 degrees east, so the dish is like this, to the lowest that I've installed in Cyprus, 43 degrees west. So from Cyprus we have the ability to see all the satellites that cover Europe, plus all the satellites that cover Asia. While from Europe, they can't see any of the Asian satellites. So here we also monitored all our programs, because on the French side, RFI International, we have 270 stations around the world that are owned by the government, the French government. So we have 93 satellites that we use. A lot of those are for the Asian side, that in Paris they have no way of monitoring them. So what I do here is, I bring down the program and I send it back to Paris so they can monitor it there. The same with the US. We have programs that are uplinked in Washington. We bring them directly down here in Cyprus, because they're on the Hispasat satellite, which is 39 west, which we can see. We bring it down, and then we send it back up on AsiaSat, which is 105 degrees east, which is distributed into Asia. So we had this ability. Now someone's going to say to me, why are you leaving? Unfortunately, when you get accountants and politicians sitting together,
it's a lot of numbers.
The conclusions that they come out with from a financial standpoint have a basis, but from a political, a technical, and an advantage over everybody else, they make no sense. And the classical example of that, which is the exact same thing that is going to happen here, is what happened to the BBC in Ziggy. The BBC in Ziggy was pulled down because some accountant in London was told to see how they could reduce expenditure. And you know, the easiest thing to turn off is something that you cannot see and it does not affect you. And these are the problems with remote sites. You're very, very far away from where your center is. So it's very easy for an accountant to say, let's shut that down. What happened there in Ziggy? In Ziggy, they spent $5.5 million 3 years earlier to refurbish the towers completely. They refurbished the towers. They put new curtain antennas. I mean, it was something that took 9 months. And 3 years later, they brought everything down. And the ironic thing, 4 months later, they woke up in the BBC and they said, what? We've lost all our coverage in the Middle East. What happened? It's too late.
Yeah, it's all done.
The same thing will happen here. Because if anybody believes that the Middle East is going to stay safe, all you have to do is go back a week. If you go back a week everything was hunky-dory. 4 days ago, everybody was talking about World War III. Today, everybody's saying, I think it's all right. The Middle East will never be all right. So, today you may not be the most important place, tomorrow it will be. And unfortunately, with these type of sites, because you use such high power, you can get your licenses from the government. You can get your transmission license, because with the closing of this site, the Ministry of Communications in Cyprus, Singinon Gergo, from us, every year we're getting 1 million just for the licenses. 1 million for the licenses. So you understand, just from us, if we exclude the 11 families that were working here, they've nearly lost 2 million just like that. That excludes the money the Electricity Authority were getting from us. So for sure the government want you. What's
the capacity. Έχουμε εδώ νομίζω, ναι. Ελάτε να δείτε, θέλει να δείτε τους πυκνοτές.
These units are 23,000 euros.
Ελάτε να δείτε τα capacity.
From here you can have a free one.
Τέλειο. Γυρίζει από πάνω.
Motorized?
No. These are 23,000 each. And there's only one company in the world that makes them.
40,000 volts.
Yeah.
We have a special machine to burn the oxygen and test the voltage.
So that one comes like twice the voltage.
Θέλω το.
Θέλεις το για το Maghreb, ναι?
Ναι.
We are looking for these things to be magnetic loops where you have very high voltage.
Πρέπει να κοντεύει τα 10.
Γράφει πάνω εδώ δάμε. 1000 picofarads, 5-10 κιλά.
Και είναι και silver plated.
Yes.
Εν τω εξή απαγορεύεται να αγγίζουμε εδώ.
Άμα δουλεύει.
Καλά,
So you use this to tune the
In the tuning circuits of the output of the transmitter, you tune
The
them
low
to
pass filters?
Yeah, you tune them to maximize the output.
so you match that to the antennas. So it's the antenna matching units.
Well, it's the transmitter matching units, and then the antennas have their own matching units.
So you match it to the feed line.
That's right. You match it to the feeder.
Your feed line is this pole thing.
That's right. We'll go down now, and I'll take you down and show you.
Very nice.
Ας δείξουμε και εμείς. Αυτή είναι η μηχανή. Μπαίνει μέσα το capacitor. Μπαίνει μέσα το capacitor. Τώρα μπαίνει εδώ μέσα και έχει εδώ. Αυτό είναι η άνοδος. Μπαίνει πάνω. Έχει ένα transformer το οποίο έχει κάτι high voltage με λάδι μέσα. Το οποίο κάνει, πώς το λέμε στα αγγλικά, όχι regeneration. Μπαίνει ένα σύστημα μέσα, αν το voltage που κάνει short, χαμηλό, δουλεύει και κρούζει το οξυγόνο όπως είναι μέσα. Διότι
Καινόν αέρος που ήθελε μέσα.
Ναι, πρέπει να είναι καινόν αέρος που μέσα. Όταν είναι σε λειτουργία όμως, κρούζει μόνο το οξυγόνο, δεν έχει καμία. Αλλά αν μείνει εκεί ένα χρόνο το capacitor πρέπει να κρούσουμε το οξυγόνο.
Άρα το βάζεις και με έναν πράγμα.
Το βάζουμε εδώ μέσα, ναι. Και είναι κλείει, τώρα είναι σπασμένο εδώ, κλείει για να μην και πάνω είσαι πεθαμένος. Δεν τρασφώνουμε με λάδι.
Ένα λεπτό δεν είδα.
Τούτο είναι για το... Έχουν ένα filmmeter. Είναι homemade. Είναι homemade.
Filmmeter.
Τούτο είναι bridge. Είναι bridge τούτο. Μετρούμε το επίδας στον αντένα.
Antenna bridge.
Yeah.
Americanico.
In China,
This is the capacitor. This is for charging and decharging the capacitor.
How to call it in English? When we...
To rejuvenate.
Conventional electricity.
No, rejuvenation.
I have one, a small one for the electrolytic
Yeah,
capacitor. I forgot the name.
They have to be done every year.
Yes.
Every year.
Because you
How many years? Wie viele Jahre haben Sie?
Και με τα διαφημιστικά της γιαγιάς σου και
Όλος είναι Αρμένιο με τον γιον του. Οι υπόλοιποι είναι μας στην Κύπρη. Ποιος με ρώτα για τα... Κάμια φωτογραφία. Τώρα θα να φέρω
Each antenna system, at least on the P4, the antenna system is made up of two sections. You have the senders, which are the towers, so the towers are illuminated completely, and the ground plane, which I'll show you, which is on the ground, which for the P4 we have 33 tons of copper.
Are you removing that actually from the ground? Yeah. So it's you less carried and how
No, it's on the surface.
I think
It's on the surface. I'll show you. Yes,
cables.
our license specifically stipulates that when we leave the site, we have to return it back to
As
how
it was.
What about all these concrete bases that are scattered all over the place?
These concrete bases we'll remove.
And at the entrance.
No, those ones were before we came.
So you're leaving those.
Well, yeah, because it stipulates that anything based on what we have.
The lighthouse will stay, right?
Yes, the lighthouses belong to the state. You're going to get the opportunity to see something that you won't see again. Unfortunately, I shall take you into what we call it Frankenstein's laboratory. There's not so much room, so come in one by one and have a look at some tuning coils and things that you won't see again. All go in.
Που χτυπάνε ο αέρας. Είναι το πιο κάτω. Χτυπάνε ο αέρας, το νερό πάνω. Έτσι να έχω την ταράτσα για το... Εγώ μια φορά μόνο. Είδες τα φύλλα που το μετάλλο που πάνε κάτω στη γη, το χαλκόσκινο.
Ναι.
Το πρασίνι σε μπράχα.
It's from there the ground plane goes out.
And they are. And
Είναι
they are leaves
μερικές
or-
εκατοντάδες τόνους και στέκονται πάνω σε γυαλί. Οι άλλες οι αντένες στέκονται πάνω σε ένα γυαλί μόνο. Έτσι κάτω, βλέπετε, φαίνεται το insulator.
Γιατί τούτη έχει παραπάνω.
Είναι πράγμα. Είναι από εκεί. Είναι από εκεί.
Τρία γιαγιά.
Κυριακές γιανούρες που έχουν τηλεία. Εκείνες έχουν ένα μόνο. Οι παγιές. Είναι οι πρώτες μας οι αντένες, είναι με έναν insulator, αλλά πολλά χοντρό.
Είπε μας, ναι, 150 κάτι μέτρα.
133 και μισό.
133. Ναι. Ναι.
Είναι 133 μέτρα και μισό.
Μες στη Λευκοσία.
Στέλναμε πάνω, και ο Μιχαήλης. Και ο Μιχαλάκης ο Γέρος Κολά. Και ο Μιχάλης ήταν τα μέσα παλιός. Ο Φασαρίας. Ευκέναμε και πάνω και έχει μπαλκόνια. Έχει μπαλκόνια πάνω και ξεκουράζεσαι. Και παίρναμε τέλεια πάνω για να αλλάξουμε τις λάμπες του για τα αεροπλάνα. Ναι, τα μπαλκόνια, ναι. Και κάθεσαι και ξεκουράζεσαι. Αν πάει και πάνω νιώθεις το σούσμα που κινείται η αντένα. Έχουμε στη λέει, ευκέναμε σαν τα πουλιά.
Όταν πρωτοπήγα στη Σιτά, δοκιμάσαμε για ρίγια.
Εμείς είμαστε γεροί, αστρογράφοι θα φτιάχνουμε.